So here we are at last, ready to share live images of the near-Earth Asteroid 2020 UA and its extremely close approach with our planet. I'm just checking the very final thing to be sure that everything is up and running, my friends. All this is happening thanks to the Virtual Telescope Project platform. I'm just checking and I see that everything is running, so I confirm, at least from my side, that we are really ready to start this live feed officially. So good evening, ladies and gentlemen. Gianluca Masi speaking from Rome. I am the founder and the scientific director of the Virtual Telescope Project. We are here because tonight we will be lucky enough to have clear sky, not obvious this time of the year here in Italy, to share with you what we really love more up there. Asteroids, my friends. And all this is happening while tonight the NASA OSIRIS-REx space mission is just taking some very precious samples on asteroid Bennu. And on the same night, as you can see, a small rock, asteroid 2020 UA, is safely coming very close, extremely close to us, reaching the minimum distance in a few hours of 46,000 kilometers from us. That is just 12% of the average lunar distance. It is time for me to start sharing with you images coming from the telescope, but before doing this I want to show you and just to share with you what is going to happen. As you know, the Virtual Telescope Project offers the opportunity to spot what is happening there live in real time. Our telescopes are placed in central Italy and we are able to share the view of those telescopes with the community worldwide. And for this I want to thank the technological partners of the Virtual Telescope Project. They are Unitron Italian Instruments, Software Bisq, C-Web, Santa Barbara Instruments Group, Brainwave Instruments, Bader Planetarium. And I also want to thank the ANSA press agency in Italy, and in particular their scientific board, and all the media worldwide who share the opportunity of this for you to join this live feed. It is now time to go looking at this object. Please consider that what you are seeing here is the interface of the telescope. I am in Rome. The telescope is about 100 kilometers south of Rome, and you are somewhere on this planet. So nobody is physically at the observatory, but technology is making possible for everyone out there, you and me in particular, to see what the telescope is tracking and what the telescope is observing. The Virtual Telescope Project has been sharing the cosmos live since 2006, so a number of years ago we started this adventure, and we are very happy to see how happy the international community worldwide is while we are doing so. But as the telescope is placed in such a remote place, we need a software to control the hardware there. We have to ask the telescope to point our target, in this case the asteroid, and once the telescope has pointed the target, we have to track it if it is moving pretty fast across the star, as it is the case for this object. And it is not enough, because you also want to see the object. But you are at home, the telescope is in central Italy, and the only opportunity you have is to use an electronic or digital eye, that is a very sensitive camera installed on the telescope, and by controlling that camera we can grab images and see through the telescope. That is like if you were there. In other words, it is like if you were the astronomer on site, even if you are in the comfort of your home. You can see there are a number of stars. This is a graphical representation of the night sky above my telescope in central Italy, and you can also see here in the star map there are a few symbols. In particular, you have the constellation names. You can recognize Orion here. You can recognize the winged horse Pegasus, the Ursa Minor with the polar star here, by the way, and so on. But in particular, you have this yellow circle here, and it is where the telescope is pointing at a given time. I already asked my telescope to point the asteroid because I already started acquiring images because I was interested to cover quite a bit this object while waiting for the live feed to start. And once we are there, the telescope is already there, it is tracking the object, and the first things to do is just to take an image. I will take an image just collecting light coming from this faint object. I will tell about this object in a few minutes, and then we will look at the result. Right now we are taking a photo. This is a long exposure, just a 2 seconds long exposure, and you can see here this is the real-time images, my friends. This is just happening live, and as the telescope is tracking this fast moving close approacher, this asteroid, you can easily recognize that even 2 seconds are enough for you to see that the asteroid, which is carefully tracked by the telescope, is visible as a sharp dot of light here, while you see stars on the background are leaving trails. This is, to me, quite important to understand because our telescope has the amazing capability to track basically any given object at any rate up there, and this is very important when you have these very close approaching objects that will apparently move up there pretty fast. But if I take a longer exposure, for example a 2 seconds exposure, I will see twice basically the length of the star trails, because more time, integration time, means more motion. And in fact, you can see that star trails now are basically twice the length they had earlier. But this is a bit simple, too much simple, because while the asteroid is approaching, its motion is increasing pretty fast. So there is an acceleration, and of course, at some point, these 4 seconds will show a much more longer trail, my friends. And all this, again, I repeat, is happening in real time. And for me, it's very important that you understand this, because the Virtual Telescope project is just sharing with you the cosmos live, and for me this is important. What the images you are seeing are obtained now. In Italy we are just 7 minutes, you can see on the bottom right, past midnight, and I will ask at this point our telescope to take a number of images back to back, but I want to just to give you an idea of the fast motion of this target, just taking a 30 seconds long image. When I talk about long exposures, I'm confident you understand what I'm saying. If you are taking an image, a photograph at night, you have troubles because you don't have enough light. The only solution is that you increase the exposure time, and this is something that people with an interest in photography know very well. And we are taking a 30 seconds exposure. There is a countdown running on the upper left here, and once the exposure will end, the image will be downloaded from the camera to the computer. It will be digitalized and then shown here. And you can see how long star trails are now that we use a 30 seconds exposure. Time for us. I want to take a small a number of images. If you don't mind, let me try. As I want to create a movie later, hopefully tomorrow, but I want to be sure that I have enough. Okay, I think perhaps I can double the size of this, and I will go with an arbitrary number of images, and we'll do this. Okay, I just asked the telescope to take a long sequence of images back to back so that we will have always a fresh, a new image to look while I will tell you about this asteroid. I already told you about the name of this rock. It is named 2020 UA. The first number is just the year of discovery, while the two letters are telling us, in a way astronomers love, when in the year it was discovered. It's just telling you that this object was discovered in 2020 in this period of the year, that is in the second half of October 2020 basically. And this object has been discovered earlier this month. It has been found by the Mount Lemmon survey in Arizona, and it has been discovered on October 16, so just a bit more than 5 days now. And its size is estimated to be somewhere between 6 and 13 meters, and the source for this dimension estimate is the NASA JPL, the Jet Propulsion Laboratory, and they are doing a superb work about this object. So we have said this has been discovered 5 days ago, 16 of October. Its size is between 6 and 13 meters, and what we know is that in more or less 3-4 hours, I want to tell you the right time by the way, this rock will be at its minimum distance from us, that is 46,000 of kilometers. It is very close, extremely close on an astronomical scale, but still very safe, because while it is coming so close, its trajectory is very well known, and we can absolutely say that it will not hit us. This is very, very important to keep in mind, my friends. Otherwise, you will not understand why, despite the short distance, this is a safe approach. Science is beautiful for this. And just to give you the time of the rendezvous between our planet and this object, the minimum distance will be reached in about 3 hours and 50 minutes by now. It will be early in the morning, tomorrow morning in Italy, and it will be just the first part of the night for our friends in the US. As you can see, we are beautifully tracking this object. This asteroid is here, and it is sitting in the very center of our image. And this is telling you how beautiful our telescope is in doing its tracking job. The telescope we have here, we are using here, is one of the most, I would say, productive in this kind of observations when there is an asteroid so close and moving pretty fast and so fast up there. Our telescope is basically able to track it without problems, because we have the right hardware, we have the right software for this task, and we are very proud that we are able to share with you a perfectly tracked object. Trust me, this is moving pretty fast, and there are just a few telescopes able to track this object so well, my friends. Now I want to do another thing, if you don't mind. I want to also reduce the resolution of this, and also want to change the name of the file so that I will be an easier life later when I will try to put together all those things tomorrow, creating time lapse. I also want to thank you for your time, for joining this live feed in this very spectacular night while the Osiris-Rex space mission by NASA is basically taking very precious something, making history tonight. The probe is just taking a sample of asteroid Bennu, and it will bring it back to our planet in the future, and this will help us understanding about nature of asteroids, and of course they will tell us a lot about the evolution, the birth of our solar system, because we are observing this this extremely close approach. Of course, the first question is will the asteroid hit planet Earth? The answer is no in this case, but we cannot be sure that an asteroid at some point will not hit us. It will happen in the future for sure. It happened in the past. It will happen again in the future. But the only solution here is that we study these objects so that we can understand the near-Earth asteroid population, that we can estimate the impact frequency, the impact conditions of a given object, and just to put out there our effort to deflect, for example, this object. And studying asteroids is important also for this, but also because we really know that asteroids play a very important role in the formation of our solar system. They are the bricks just building planets, you know, and the idea of a collision, while it is not an happy idea, I understand, is just an echo of a mechanism which in the past billions of years ago has made possible for our planet Earth, for example, to build. Without collisions, it could be impossible. It would be impossible to explain what happened and to explain the existence of our planet and the other planets. So collisions were essential to our solar, in this sense. Without collisions, planet could not be built, okay? But these collisions continue today, even if at such very much lower rate, luckily for us. But they are important because asteroids can really reveal the past of our solar system. So studying them is very, very important, my friends. Sorry. And this is safely flying not far from us. Let me calculate the distance this rock is having right now. I want to do this right now with my calculator here. While we are talking, this object is almost exactly at 100,000 kilometers from us. It is really, really amazing. This is 1/4 basically of the lunar distance, but this is still much more than the minimum distance that we will have in about 3.5 hours by now, when this small rock will be at 46,000 kilometers from us. Safely, I will say, and I will always repeat. It is important to keep in mind that we really don't have to worry about this rock. At some point we will discover an asteroid on a route of collision with us. This is why it is extremely important we understand the near-Earth asteroid population to be ready one day to save our planet, for example, by deflecting this dangerous asteroid. But also, do not think of an asteroid just in such a bad way. That is, they are very positive arguments in favor of an asteroid, because as I told you, asteroids can tell us a lot about the past of our solar system, and we are here, our planet Earth is here because of asteroids, because those collisions in the past, billions of years ago, made possible asteroid after asteroid, piece after piece, to build planets like our precious Earth, of course. And this is truly important. Also, asteroids can have precious resources, and one day we can go there, take those resources, come back to our planet, and have a better life, everyone on this planet. And this is why also it is important to study these objects. And we are living very exciting days, as the OSIRIS-REx space mission right now is showing us so well, my friends. We are still tracking this amazing object, And image after image, you can check the number of images here, 49 on 90, and image after image you can see the image is updated. I see also there are some clouds, but nothing serious for now. I've been worried about clouds because we had troubles. It is October, and October is not the best month for astronomy in Italy. Not to tell you about the upcoming winter, but that is. This is what we can do. And we are still tracking this small object. As I told you, the dimension of the asteroid 2020 UA is between 6 and 13 meters, as the NASA JPL says on their website. Hopefully you are having fun with this and you can easily understand how I'm facing the first winter troubles. But the object is beautiful here, and while it is very late, we are 21 minutes past midnight in Italy, it's a joy for me to be here and use such a wonderful results how the virtual telescope is sharing and bringing to you the cosmos live. This is for me something honestly priceless. And by the way, you can support the virtual telescope project while you are here enjoying this for free. It doesn't mean that doing this is free. You can easily understand that the technology behind all this is not cheap, and if you can support us by a donation, the amount is up to you. You are extremely welcome and precious, because you will help our project to survive. If you want to contribute, just visit the www.virtualtelescope.eu page, our website, and from there you can easily find the donate section and help us that way. And we will send you a few things to thank you for your support. Before closing this, I would like to take a long exposure, a 3-minute long exposure. This is a lot, because in 3 minutes the object will really move a lot and you will be impressed by the length of the star trails. And before closing, after that, I will also show you the opposite situation. We will ask the telescope to track the stars, something that a telescope does basically all the time, and we should see a little trail that will be the asteroid. But the 3 minutes long exposure started. 150 seconds left. You can see the countdown here. We have just to wait. Right here we have the last images from the previous section. Gianluca Masi speaking. I am a professional astrophysicist with such strong love for astronomy, and with the real, I am obsessed by the idea to share all this with people like you. I forgot how many asteroids we shared over these more than 14 years now since we started our virtual telescope, and some of those objects, some of those asteroids were truly historic events, with objects coming closer than the geostationary satellites, for example, and this happened last September too. So if you want, you can easily keep an eye on our activities and our live events. The best way to stay updated is just to join our Facebook page, the Virtual Telescope Project Facebook page, and from there we promote our activities. And keep in mind, all our events are available for free, and we do not ask money for our events. Sometimes we offer some upgraded versions of our live feed to our supporters, but people are always welcome to join us for free. We are basically 20 seconds left from the end of this exposure. Then the image will be transferred from the camera to the remote computer, and then the digitalization process will end, and we will see the image and be ready to see very long star trails. I'm never bored to see this. Look, here it is. Look how long the star trails are, so long that you don't see any trail completely inside the field of view. They start or end inside the field of view, but you don't see the other end because this is moving pretty fast. Let me check an updated distance for this. We are 3,000 kilometers closer than earlier. That is, right now this object is at 97,000 kilometers from us. That is 1/4 of the average lunar distance, my friends. But I promised you before closing this that I was going to show you this is not easy to do. Let me see if I'm able to show you the asteroid as a trail. Now the telescope was tracking the stars, so the object was a sharp dot of light, the asteroid was a sharp dot of light, and the stars were leaving trails. But here you see the opposite situation, my friends. Hope you appreciate this. This is the telescope tracking the stars. Now the stars are dot of light, but the asteroid left these nice star trails there, my friends. I want to take 20 seconds exposure if I can. Not bad at all. Let me ask again the system to slew and take a 30 seconds image. Look, even a couple of seconds are enough to have a trail of the asteroid. I find this pretty funny because earlier we were looking up there from the point of view of the asteroid, okay? We were basically traveling with it across the sky. But now we are basically traveling with the Earth, if I can say so. And of course, you can see the very peculiar motion of the object. Not sure how evident the star trail will be, because the longer the star trail of the longer the asteroid trail, the faintest it is, because the background up there of the sky will make things harder. This is pretty interesting because you can see that the trail is not of constant brightness, because the object has an irregular shape and rotating. It is reflecting a variable amount of solar light, and this is just reflecting in evolving apparent brightness. It could be even a cloud, but if we will see this also in the other images, we will easily confirm this. And in fact, we can easily confirm this. Now I would like just to, let me see. I want to do something manually. As you can see, all this is happening live. This is just something I'm doing with you in this very moment. My goal is to put the object in the upper part of the frame, then taking a number of images. How fast this is, my friends. I want to take let me see if I'm able to, meantime I'm preparing to the next step. I'm just trying to put the trail on the upper part, so I will have the maximum amount of time while it will be crossing the field of view. Okay. And then I will start our sequence. I think this could be enough. Just changing the file name here. Sorry, let me check again to be sure. I could do this offline, but I still wanted to share with you this nice experiment, if you don't mind. Okay. Okay, I think I can start with this. Let's see if we will have 3, 4 trails so that we can estimate the rotation of this object by looking at the variation of light. As we saw, that if you leave the asteroid trailing, the trail has a variable brightness because the object is rotating. Its shape is irregular, of course, and it is just reflecting us different amounts of lights. And unfortunately, we will have to repeat this, but this is the right approach, I believe. This is just a calibration image, so we will see the same image but with less noise. Hopefully, yep. But perhaps the best things to do is this. Trying again, my friends. We are doing real astronomy together. the trail here is the asteroid, of course. Perhaps this time it should work. So in short, we start. Oh, I'm sorry, friends. Okay, as you can see how hard is to handle an observing session when an object is moving so fast, because while you decide, while you understand, while you plan, it already moved significantly. My goal here, now that we are tracking the stars and leaving the asteroid to trail, is to record a relatively long trail of this object so that we can see, we can spot if there are variations in brightness across the trail connected to its shape. Okay, perhaps this is the good time for us to get something useful, because here this should be the object, so I do expect the trail to start not far from the border, so we will exploit the entire amplitude of the field of view with 3-4 images. Let's see. This is something I did not schedule. This is an idea I had right now. And let's see how the trail will behave. But you can easily see its brightness is not constant at all. Image after image, we will have another segment, and you can easily see that this image, the trail is not constant in brightness. I think this is quite apparent, my friends. And as I expected, we will have likely 4 trails inside the field of view. New image, so the trail is here, and clearly the brightness is not constant. You see, here it is brighter, here it is fainter. This is because the asteroid is just spinning. And this is something we can perhaps use to determine the rotational period of this object. But with these friends, I think we had enough. So I was very happy that we observed together Asteroid 2020 UA while safely coming extremely close in about 3 hours and 30. It will be at 46,000 kilometers for us, a bit behind the geostationary satellites, and the Virtual Telescope project has been able to bring all this to you live. And in this very moment, I had a communication that OSIRIS-REx grabbed a sample of asteroid Bennu, and this is something amazing to celebrate. This is really something historic. That said, thank you for joining. Thank you for staying with us and observing this a close approacher via the Virtual Telescope project. It's been a privilege for me. Gianluca Massi from Rome is thanking everyone there, also our technological partners, Uniton Italian Instruments, Software BISC, C-Web, Santa Barbara Instruments Group, Plainweb Instruments and Bader Planetarium. And I also want to thank all of you who decided to support the Virtual Telescope project by donating everything you want. You are welcome to support us. This is the only source of funding we have, especially in these very hard times, with the pandemic all around. But we are still keeping this beautiful opportunity alive to bring the beauty of the cosmos to people, no matter the hard times we are living. So please consider to support us by donations, and for doing this just visit the www.virtualtelescope.au website, and from there you will easily understand where to click to support us, to donate to us. That's all. Gianluca Massi, Virtual Telescope Project, is sending his best greetings to everyone. Keep looking at the stars and keep looking up via the Virtual Telescope Project.